Okay, so I'll be your host, and by now maybe you might have known my name. But anyways, you are the last time I know that we have people from Ethiopia, Kenya, Nigeria, and the rest of that. Oh, I think one of the TM's mic is on. Oh, are we all joining from the virtual world? Nobody is mentioning where he's joining us from. I'm joining from my room that's located here in Nigeria. And all right, so while you are doing that, what are some of the rules of engagement? If you have any questions, please use the Q&A, and you should also feel free to use the chat so that we can interact with one another. Most importantly, you should listen, learn, and engage. Mm. Thank you, Najoli. Kenya is represented. Oh, I also think South Africa is represented. Now, before we dive in, what would be the very first thing you do if you won $1 million right now? So please let us know in the chat. Welcome, Kenya, from Johannesburg, South Africa. Christians, Kenya also. Nice one, nice one. So to the prompt, what will be the very first thing you do if you won $1 million right now? No one? Oh, okay. Oliver is saying, I'll first tell my body sorry and buy KFC and Big Fanta. Okay. Dennis is saying, I will draw a small amount to be sure the money is in my account. Okay. Ngobe is saying, double or nothing. Hmm. Do you mind to tell us what that mean? Busiswe is saying, go on holiday. Oh, Michael is saying, set up a trust fund, do a cars business, and get a G-Wagon. Nice one. Kiza is saying, building my own dream house. John is saying, disappear to an island for a month just to sober up. Okay. Christine, I'll let it settle in my account first. Sometimes that money can make people mad. Like there's one story like that. One Nigerian police, like is it 15 mil is it 5 million naira? So the person was like dumbfounded. He kept crying. So the politicians went into his room and came back and say, why is this man crying? They told him that it's because of that gift that you give him of 5 million. Then he said, okay, this is 15 million, go and die. So if 1 million, I mean, if 5 million is going to make him cry, 15 million will make, okay, Oliver is saying, the rest put it on sporty bet. Wow. Hmm. He must have a big mind. 1 million. This is deep. Kaya is saying I will invest 30% and diversify the rest in other portfolios. Smart move. Oh, Oliver is saying it's also about risk. Okay. So for me, if I get like $1 million right now, the first thing I'm going to do is I'll just shut down and rest for like 1 week, or I can even extend it to like 1 month. Then I will check my budget to see those things that need my urgent attention. Then I'll start fixing them. Well, I think with even with $1 million, I think all my budget, I mean all my plans, all my financial plans will be solved. So I'll just go ahead and solve them then. Maybe invest the rest and make my life easy. Well, nonetheless, I hope you all get $1 million now or in the nearest future. All right, so what do we want to learn today? We want to revise regression. Okay, John is saying plus, I will know my true color. Yes, money have a way of bringing the true color of people. Like some people, when they have money, the way they behave, their behavior is different from when they don't have money. Like I mean, they will be pompous, even the way they walk. It will be showing that they have arrived. And yes, so now let's dive in. All right, so for today, I think what we will do, I want us to do, since this is revision, and I want us to do it together. What do you think? So if that is the case, meaning I may not need to like copy the link to this and give you, so we'll just like I'm going to get a fresh notebook. You can also get the same from your own end. If you like this, you can give thumbs up. Or if you want us to just walk through this, so we can also do that. Today's session is not going to be long, so we'll just mm. So what do you think? Should we work together on this, or should I walk you through my notebook? No response. Okay. All right. Vera is saying we should work together. I also want us to work together because that's how we move. All right. So what problem are we going to solve? Well, the project is predicting fuel efficiency. So for example, if you have all right, so this is our project. So we want to predict fuel efficiency. So when we say fuel efficiency, we mean the miles per gallon to reduce carbon footprint and enable data-driven policy. So, automobiles are not consuming the same amount of fuel to cover the same amount of distance. So depending on the load, the engine size, and the car manufacturer, that will determine how efficient these automobiles can be. All right. So in order to, here, the main purpose of this is to get to know how efficient those vehicles can be. Can we be able to predict that? If we can be able to predict that, then there are so many economic advantages. So government worldwide are under increasing pressure to reduce greenhouse gas emissions. So right from the transportation sector, one of the largest contributors to environmental pollution is the greenhouse. So fuel consumption in vehicles is directly linked to carbon emissions. So, whenever fuel is burnt in any automobile, the byproduct of that, or the waste product of that, is one of those waste products is the carbon dioxide, which is harmful to the environment. So therefore, making fuel efficiency measured in miles per gallon, trying to determine this is a critical metric for environmental policy, economic planning, and sustainable development. So the task we are going to deal with today, assuming you are a data scientist working for a government agency, your task is to develop a predictive model that estimates a vehicle miles per gallon based on a technical design characteristics such as the engine size. So the engine size is one of the determinants of how efficient that automobile can be. The horsepower, that's the engine power. Also have the weight. So the heavier the vehicle, the more fuel it needs to consume to cover a given distance. Number of cylinders. So vehicles can have a different number of cylinders, most especially those olden days vehicles. You can have vehicles with 3 cylinders, 4 cylinders, 8 cylinders, like that. And origin. Maybe some countries are more efficient at creating automobiles than others. By accurately predicting fuel efficiency, the government can better understand which vehicle attributes or contributes most to fuel consumption and emissions. Now, beyond informing the government to make policies that can make the world a better place, predicting MPG can do things like cost optimization for citizens and public fleets. So you as a citizen, you also like a vehicle that is efficient, because it means you are going to spend less, most especially currently that the world is undergoing energy crisis, right? So improved transportation planning, that will also inform taxation and subsidy policies. When I mention tax, I know some people will say, what is this one? See, support for automotive innovation. So if we can be able to predict this, then some companies can innovate, right? So that they come with vehicles that are fuel efficient, enhance consumer awareness, and national energy conservations. So the insights that you can get from this model can help with evidence-based fuel efficiency regulations, high emissions, vehicle profiles, and targeted incentives program for low emission vehicles. So the government can say, okay, all those companies that are having lower fuel efficiency, high fuel efficiency, this is bonus for you. So this kind of exercise can help you with that. Reduce national carbon footprint. All right, so about the data sets. So the data set that we're going to use is the auto MPG data set, which includes features like the displacement, the horsepower, acceleration, and the rest of that. All right, so since we are going to do it together, This data set, you don't need to download anything in order to make use of it. It is already available on sklan, and not only that, it is also available on Seaborn. So in this case, maybe it will be good if we can itemize the tasks that we're going to do so that we can easily follow them. All right. So please, in the chat, let's have a clean slate. So can you list the the tasks that we're supposed to do in order to make our life easy? Anyone? First of all, I know that we need to load data. All right, I see one response. Import libraries, okay. That's correct. Import libraries. Which one again? I know we need to load data, then which next? Explore the data. Thank you, Vera. I wish you $1 million soon. Anyone again after EDA? Anyone? What's next? Oh, we also need to do the modeling. Ngobe is saying, is Colab better than Jupyter? Well, it may be a matter of preference to some extent. However, there are some features on Colab that are not on Jupyter. And Jupyter may have one or two advantages over Google Colab, but I like Colab. I know Shegun use Jupyter, so I don't know. Shegun, maybe in the chat. Can you tell us which one you prefer? I know based on your work, it seems you prefer Jupyter. So Shegun prefer Jupyter, I prefer Colab. And there are so many advantages that I get from using Google Colab. So that's why I prefer that. All right. Yes, they are more or less the same, although they may not also be the same. For example, like if I want to share this, I can easily come here and say share. So we can work together on this notebook. All right. But that is not possible with with Jupyter. I know somebody may say you can just copy it and share it. Sorry. And share, you can just share the file, the whole file, but can you work concurrently? I just know. All right. So which libraries are going to be important for us? So the first thing that we're going to do is to import libraries. All right. So the first thing, we import the usual. So we import pandas as PD. We import numpy as NP. Then what's next? So this is the pandas is for data analysis, NumPy is for numerical analysis. Then, what will help us in loading this data? We say we are going to use Seaborn. So we import Seaborn as SNS. All right, so after loading the data, we will need to do EDA. So pandas and NumPy can help us with EDA. Yes, Vera is saying matplotlib. We also need to import matplotlib for visualization. So here we say import matplotlib dot pyplot as plt. Then what again? So under EDA, I think the pandas for data analysis, that will help us with our own EDA. So maybe the next thing that we need to do, that's data pre-processing is sklan. Exactly. Thank you, Vera. So here we say from sklan dot. So under modeling, there are a couple of things that we need to do. First of all, under modeling, we need to do what? Pre-processing the data. That is 1. 2, we also need to what? We need to import or instantiate the models. Then after instantiating the models, what else? We need to train the model, and after training, we need to what? We need to test the data. So we need to also split the data. So after splitting the data, we need to evaluate the models. All right, so we need to import all the libraries that are going to help us to achieve this. So from sklan.pre-processing, import what? Standard scalar. From sklan dot what again? We need to do model selection. We import train test split from sklan dot what again? So now we need to instantiate the models. However, before we instantiate the models, we need to import them. So for the purpose of this exercise, let's use random forest regressor. And the random forest regressor is in ensemble, it's an ensemble method. So we need to import it from there. Import random forests regressor. Let me run this if there's any issues. All right, what again? So for the purpose of this, I will also want us to use XGBoost. All right, so maybe we can compare 2 of the models to see which one will perform better. So XGBoost, this one we import it from XG boost, as the name implies, import XGB regressor. All right. What also can we import? Can anybody suggest any random, any regressor that we can use here? Oliver is saying sklan.org. This might be useful. This might be a useful site. Definitely is useful. Yes, can anybody tell us any other model that we can use just to compare which one will perform better? Anyone? Label encoding. So label encoding is actually used like when you have categorical labels. So for example, if the outcome is true or false, or yes or no. So if you pass yes or no to the model, it will not understand it because it is text. It is numerical text, right? Okay, somebody is saying we should import linear model. All right. There. So from sklan dot so this linear model, is it a linear model? Import linear regressor. Oh, somebody is saying, what about SVM, support vector machine? Okay, let's try that. From sklan dot so this support vector machine should be under which support vector machine is under which of the libraries? Okay. So for us to see this, what we can do, we can say help on sklan. No, sklan is not defined. Okay, that's true. So how about if I say import sklan? So from here, this will now be defined. All right, so where do we find SVM, support vector machines? Let me do command F SVM. Support vector machine package is under I have only one of this. Maybe this is taking time, so I know when you get the notebook, you can explore that. So for the purpose of this, I think we can restrict ourselves on these three. Oh, somebody is saying from sklan. Olua Bukola, thank you, from sklan.svm. Import SVR. Okay. Let's see how that goes. Okay. Yes, it will work. So now let's restrict ourselves to this. How many are they? 1, 2, 3, 4. So having done that, the next thing is to what? To load the data. So the next item on the agenda is load the data. Right? So to load this data, here we can say our df is equals to SNS dot load data sets, and the name of the data set is MPG. Right. So having done this, we can now go ahead and do our EDA. So we can say df.head. So this is our data set. You can see on the data set we have miles per gallon. So like this first car, which is Chevrolet, it will cover like 18 miles per gallon. Meaning if you have like 4 liters of your fuel, it's going to be 18 miles only. It is having 8 cylinders. Displacement is 307. The horsepower is 130. And the weight, this is the weight. And this is the acceleration. This is the year of the model. And this is the country of origin. And this is the name of the car. All right. So next, what can we do? The next we can say df.info. We all know this. So df.info, we can see we're having 398 no null values. All right. So we can see we also have like 8 columns. So maybe the data set is looking clean. We can also say df.describe. So when we say df.describe, this is what we have. But let me ask this question here. Are all the columns included in this summary stats? Yes or no? Are all the columns in the data frame included in this summary stats? No. So is it possible to include everything here? Yes or no? Is it possible to include everything here? So please, how do we include everything here? Those of you saying yes. How can we include everything here? Anyone? Going once, going twice? So, that's one thing I like about Python. You just use the word include. Like Python is close to our daily English. So here I use include. Oh, thank you, Hafsat. Include all. So when we do that, you can see all the columns are now included. All right. So here we can see things like count, unique. So for all those categorical variables, their unique values are being computed here. So here we can see the origin. The country of origin is 3. So we only have 3 countries here in the data sets. And the name, we're having 305. All right. So we can even see the country with the highest number of cars is USA. So that's the top. And the most popular car is Ford Pinto. Okay. You can see the frequency. So for all these categorical variables like the origin and name, they have these additional values. However, you cannot have the mean of countries. Like when you add USA to Japan, what's the mean? That's not possible. So that's why here we're having NAN for all of this. NAN for all of this. But for all the numerical values, we can see they have count is true for all of them. So all of them, they are 398, and we don't have issues with that. So the mean mile per gallon is 23 miles per gallon, and the minimum miles per gallon is 9. This car that is having 9 miles per gallon must actually be heavier than all of them, I guess. So, and we can see the 25th, 50th, and 75th percentile. I can also see the maximum miles per gallon is 46. So I think all these are numbers that are reasonable, right? And then the number of cylinders, we can see the minimum number of cylinders we have is 3. But we also have some cars with 4 cylinders and some with 8 cylinders. Then the displacement, okay, the horsepower, can have a car that is having as much as 230 as the horsepower. And the weight, this is the heaviest car. And this is the lightest car. The acceleration. Then the model year. So we can see the model year ranges from 1970 to 1982. All right. So that is that about that. However, this is not only for us to look at this and say, okay, these are what we get. So we also need to like drive some insight from this. So what are some of the insights that we can see from this? Can anybody help us with some of those insights? Some of these insights, we have already mentioned them, but I want you to mention those insights that will inform the next processing task that we might likely going to undergo, or any insights that will make you answer one of your curiosities. As you know, data analysis is all about you being curious, right? So if you are curious, that's when you begin to ask questions. So what are those insights that you can see from here? So let's start from MPG, mile per gallon. Like we can say the minimum MPG is 9. So which kind of analytical question can be asked here? Can anybody help us? Because that's the essence of the exploration. The exploration will guide you in the direction of the questions that you need to ask. So minimum MPG is 9 miles per gallon. So which kind of analytical question can we ask here? For example, remember our task is to find those cars that are efficient. So for example, let me ask this question. A car that is having 9 miles per gallon and the car that is having 46 miles per gallon, which one do you think is more efficient? Anyone? Yes, 46 miles per gallon. Thank you, Abdurrahman. Hafsat, thank you, 46. So maybe the natural question that we can ask as data analysts, we say, which car has the least MPG? So we know the MPG is 9. So which car has that? And another answer that we can see is maximum MPG is 46. So the natural question that can follow is which, for example, which car has the maximum MPG? So the answer to this kind of question will, one, for example, if you are a customer, you know that, okay, I will need to get this kind of car. All right. So maybe you say, okay, I need a car that is having 46 MPG. All right. And that's one. Maybe from the government perspective, they will say, okay, we want to know which car is having 46 MPG so that we give them some incentive. Like the company that is producing that car, we give them some incentive, right? So that's one question that can be asked. Then what again can we ask? So all this, you are doing it in order to understand your data. And okay. What other insight can we also see? For example, number of cylinders. And so now one of the things that may come to your mind when you see this, you will say, okay, we know that the higher the weight, also the lower the fuel efficiency. So is it true that all those cars, I mean, the car that is having 9 miles per gallon, is it true that it is the heaviest car in the data set? So this is a question. So how can we answer this with data analytics? So let's have this as a question. Is the car with the heaviest weight having the lowest efficiency? So this is a question, right? Then another question, maybe we'll leave it at this. Then before we dive into our modeling, another question that we may ask, we might say that, okay, on average, which of the companies or which of the countries is having the highest efficiency on average? All right, so, or I even started answering that. So what we can do, we can say which country have the have the best efficiency. All right, so now we can go ahead and start and try to answer this. Which car has the least MPG? So can somebody suggest a way of achieving this answer or arriving at this answer? Anyone? All right, so here we can say DF dot. Now remember our MPG is this. So our column of interest is MPG. When we do this, we can get these values. So for example, we can say dot mean. Let me see whether dot mean will give me what I want. So we can see the minimum is 9. All right. So how do we use this? Use this to filter our data sets. So we can see, we can use this as filter where we see whenever this, it may be possible it's not only one car that is having this, all right? So wherever df dot mile per gallon is equals to this, return true. Oh, sorry, I've done something wrong. So here I supposed to say equals to. So when you put one equality sign, that is assignment. So what I did, I overrided all the values. They were 9.0. But this is what we need to do. And so when you do this, you get this be returned. So now you can use this to filter out your data set to see. That will help you to achieve or to reach your answer. All right. Yeah, so we can see it is only one car that is having this, the minimum, and the country of origin is USA, and the model is 1970. What do you expect of an old car? And this is the name, Pi. I've never heard of a car with this name. I was not there when they use it, so you can imagine. So then, to answer the next question is going to be very simple. So I can just copy this. So here, I can see which car has the max MPG. So although here, for example, like we can get the whole data about the car. So maybe to answer the question correctly, maybe what we can do. So this is the name of the car. So here we may say, okay, how do we select this? That's to answer the question properly. We are not looking for the row. So we are looking for the car. So we say name. So this is the car, right? Now, what we can also do, we may say, okay, instead of saying this, we can make it a bit nicer by saying print what? Then we say F. So the car with the least efficiency is so here you see we are getting something that is more robust, right? I can here say dot values. Why am I having? Well, I know you can get rid of the brackets. So this is our answer, right? So here we can do the same for the car with the maximum MPG. Instead of min here, we say max, right? So here, what I can do, I can call this, what? So this is the row. So how do we reach this? So here we can do something like this, where we say the max, let's say the max is this, then also attach this. So here I can copy this. Then I will say, so instead of this, if I have a variable, which is actually how we do it, and that variable is called max, I can just pass the variable name here instead. So let me try something different. Oh. So from here, we can see, we can answer the question, Mazda GLC. Okay, Mazda GLC. Let me check the chat. I think somebody was mentioning GLK when we mentioned about $1 million. Let me check the person. So this looks like GLC. Who is that? Who is that? Okay. So maybe the comment is buried in the chat, but nonetheless. So we also say that, okay, another question that might be interesting is the car with the heaviest weight also having the lowest efficiency? So we know that this is the weight of this car. All right. So, and it is one with the lowest efficiency. So to answer that question, how are we going to do it? We can have, we can find the car with the maximum weight. Right? So when we find the maximum weight and we compare it with this, if the maximum weight is equals to this, then we say that is the case. So for the purpose of this, let me copy this down there. So for the purpose of reference. All right, so we can say df, and let me just do it, df weight dot max. It turns out that it's not the car with the highest weight that is also having the lowest efficiency. That's interesting. So maybe what can we do? Can we look for that car that is having the highest weight? Yes, we can. So how do you look for that? Well, it's the same procedure. We say df, then open bracket df dot weight equal to So we can see actually a car with 18 miles per gallon is having what? It's having the highest weight. And it is the Pontiac Safari. Nice one, 1971. All right. So, meaning our assumption is not true, that the car with the highest weight is also having the lowest efficiency. All right. So that is data exploration for you. Sometimes it gives you interesting insight based on your questions. So I will leave the final question for you to actually find the answer. So my question is, should I leave it for you or do you want us to do it together? All right. And I trust that you will be able to do it. So now let's go and do our modeling. Now to do our modeling, first of all, we need to do standard scaling. But even before standard scaling, you can see some of the columns, they are what? They are categorical. So should we include all of these columns in our analysis? Yes or no? Okay, silence means we should not include all. All right. So, okay, Hafsat, so which one should we drop if we are not to include all? Which one should we drop? Among these, which one is not going to make? Should we drop the model here? Yes, we can drop the model here and we can leave it. So we can drop this. Which one again? Yes, the origin, we can also leave it and we can use it. Yes, Hafsat, the origin. So I will like us to use the origin because I will want to show you how you can transform categorical variables. So maybe what we need to drop actually is what? This name. Why are we saying we should drop the name? If you look at this, how many cars are we having? 398. How many of them are unique? 305. For God's sake, 305 unique cars out of 398. It means the number of unique values are much, which means that column alone is not going to be more helpful in terms of prediction, right? So it's having like just the ID. So because of that, we will drop that. But we can leave the model here and the origin, and I'll show you how you can deal with this. But maybe we can iterate and also remove this and this to see whether the model will perform better. All right, so to do this, what are we going to do? So first of all, what we can do two things at once. So we need to get the X. So remember, what is our target variable? Can somebody help us in the chat? What is our target variable? What do we want to predict? Of all these variables, which one will help you with? Thank you, Abdurrahman, MPG. So MPG is our target variable. So we can get our Y. Mind you, use small y. So our Y is going to be DF MPG. So this is our Y. All right. Then next we get our X. So our X, and so to get our X, we say DF dot drop, open bracket. First of all, we need to pass the list of columns that we want to drop. So we are going to drop this MPG because that is why we are going to drop name. All right. So here we pass MPG. That's the first one. Then we pass name. And in which axis we need to specify that our axis should be 1. Right, so when we do this, we can now see that our Y is equal to this, and our X is equal to this. Now, the next step is to what? If you pass this USA as it is, your model will not accept it. Some models might accept it, but there are very few. All right, so how do we transform this? So to do that, there's what we normally do. We say X dot to what? Dot get dummies. All right, so when we do this, oh, sorry, PD dot get dummies, and we're passing X. So when we do this, what do you see? We can see here the origin, this origin column is now transformed. First of all, we have origin that is Europe, origin that is Japan, and origin that is USA. All right. So, like if we look at the first column, it is USA. So, is the origin Europe? No. Is the origin Japan? No. Is it USA? Yes. So we see this, right? Then that's how we do it until, for example, like this 394, the origin is Europe, so it is false for others. Now this true and false, you can actually convert them to zeros and ones, right? So, however, there is one problem. There's one issue here. And what is the issue? What two of these, either Japan and USA, or Europe and Japan, or Europe and USA, two of them will be having what we call multicollinearity, right? So how do we ensure that that multicollinearity is absent? So we do what we call drop first, and we set it to true. So when we do this, so now what do you notice? You can see origin Japan and origin USA, they are present. However, origin Europe, which is redundant, is gone. We have dropped it by specifying this keyword argument. All right. So if you leave it, the problem you are going to encounter is multicollinearity. And you know, multicollinearity, one of the assumptions of regression is that there is no multicollinearity, especially linear regression, right? All right, so this is going to be our new X is equal to this. All right, so what's next? Now, looking at these values also, like you can see the scale of this is from, okay, let's come back. Let me recall df dot describe. So looking at MPG, you can see it ranges from 9 to 46. However, displacement ranges from 68 to 455. And weight is even ranging from 1,613 to 5,140. So if you train your model with these variables as they are, this weight is going to have more influence on the model than the number of cylinders and the displacement. So how do you ensure that one of these variables is not influencing the model more than the others? So you need to do what we call standard scaling. So in order to do that, we define what we call scalar is equals to standard scalar. So we initialize or we instantiate. So after this, what are we going to scale? We are only going to scale X. All right, so we are only going to scale the features, or what is the problem? Okay, so we say scalar dot fit transform. Somebody may ask, what is fit transform? So fit transform, first of all, fitting, you know what this scalar is going to do is going to, for each of these variables, it is going to calculate the standard deviation and the mean. All right. Then it is going to divide them by those, or manipulate those variables by the standard deviation and their means. So when that is achieved, you'll see that the range is going to be formed.
Yes, hi everyone. Let's just remain calm for a minute so that we can give Harry a chance to get back online. I think something has happened. He should be getting back in a few. Sorry for the inconveniences. Yes, here he is. Welcome back, Buhari.
Thank you, John. Okay. So maybe let me share my entire screen. All right. So when you do the fitting, this is what you end up with. It is going to be an array, right? So we say, for then the next thing after this is to get the X train, X test, Y train, and Y test. So this is going to be equals to train test split. And what are we going to? Oh, we need to assign this to X scaled. So here we can copy this and pass it to this. Then we pass it to our Y. So can somebody suggest a value for the test size? Anyone? Anyone? Okay, Hafsa is saying, oh, we can drop without specifying columns since we are using axis is equals to 1. Yes, you can do that. But nonetheless, you have already specified the columns when using this, what is it called? This list. So here, you are specifying the list of columns to be dropped. Oh, many of you are saying 0.2, so the 0.2s have it. So the test size is 0.2. And how about the random state? Can somebody randomly give us a random state? 42. Should we use 42 because some people are tired of seeing 42? Okay. Okay, let me choose this one. In memory of the legendary series 24. I will use 24. I don't know. I watched 24 and I like the movie. I mean, I like the series, right? So, loving memory of 24. Let's use 24. All right. So now with this, what next? So we can actually go ahead and do our training. So here we say fit. All right. So remember, we have different models that we can fit on this. Now, one of the model is this. I think in order to make our life easy, let me just copy their names there. So let's start with random forest regressor. So here we can see our RF is equals to, first of all, we need to initialize it. So we can say random forest regressor. We can have an empty one, or so if we have an empty one, we can specify the number of estimators. So by default, the number of estimators, they are 100. We may not need to specify that. But what should we specify? We can specify the random state. Yes, the random state, so that our everything will be the same. So in the case of this, I'll go with half side, which is in 33. So I will use this random state. So the next one, we are going to use that of to Kozo. I hope I call your name correctly. Okay, so this is our random forest. So RF, now we can do our training rf.fit. What are we going to fit? We are going to fit X train slash Y train, right? So having done that, the next thing is rf.predict. And here we're going to pass our X tests. And when we do that, so these are our predictions. So the first prediction is saying that the RF should be what? I mean, the miles per gallon is predicted to be 19 miles per gallon. And we have another one that is up to like 28 miles per gallon. So all these are the predictions. So we can call this Y spread is equal to this. All right. So having done this, what's next? So the next thing that we can do is to evaluate our models. So how do we evaluate our models? So we can use the root mean squared. Oh, okay, we didn't import this, so we need to import this from sklearn.matrix import. We might need to import R2 score 1. We may need to import root mean squared error. Then we may need to import mean absolute error. All right, we are good to go. So now we can do our evaluation. Root mean squared error. So all we need to pass is to pass our y through, that's our y tests, and y pred. So when we do this, so we can see is very minimal. That is, the root mean squared error is very minimal. However, how can we assure that this is a value that is good fit so we can get the R2 score of the same values? Oh. All right, so we can see 88% of the variation in the data set is explained by this. And if you even look at the range of the miles per gallon, it is ranging from 9 miles per gallon to 46 miles per gallon. So just a little addition of 2 miles per gallon in the prediction is something that you can manage, right? So that's that about that. And then in order for us to do this, what can we do? So here we can say SG is equal to, let's see which one will perform better. And because of this much repetition that we have, how about if we copy this here? Then after copying the training, then we'll also copy the prediction. Then after we do that, what do we use in testing? We use the y test, y prep. We test that. So here we can call it RMSE is equals to this. I will also use this. All right, so here we can call it R2 is equals to this. So now this is everything that we do. Now, instead of like doing them one after the other, we can just say, we can just define a function that is going to help us with that. So that function, we can call it eval. So eval will take how many parameters? So first of all, we need to pass the X train, the Y train, the X test, the Y tests. So basically, we are going to pass this to it, all right? So having done this, we can now do the next thing here. So here our function should return what? One, we want it to return RMSE and out. Right. So with this, all we need to do, okay, we also need to pass the model. So the model. So here, instead of RF, I can call it model. So the model that we initialize, we need to pass that to this. So this SG, we can use this XGB. We can initialize this. Okay, so what are some of those important parameters for this one? So to get them, we can say help of this. You can see so many parameters, but let's just look for this one is learning. So here we can specify the number of estimators, the maximum depth, the maximum leaps, the maximum bin, the learning rate. If you get time, you can explore any of those parameters and make your life easy. However, for our own case, let's initialize an empty. Oh, I think I made one promise. So let's check if there is what random state here. Yes, it is having random states. So because it's having random states, let's specify the random state is equal to, okay, who was saying 42? Yes, and to Kozo. Please, if I call your name correctly, just help me and say it's correct in the chat. If not, then maybe. Okay, you say 42. Oh, thank you. I think I deserve some LPs. I deserve some LP points for calling your name correctly, even without seeing it at all before. All right, so this is our SG. So here, we can now call our eval and pass the parameters of interest to it. One is XG, and I can be lazy and call this like this. So let's see. Now we can see this is what the RMSC, and this is the what? The R2 score. So what can you say when you compare what we got here with that of random forest? Which one is better? SGB regressor and random forest, which one is better? Oh, you say SG? Okay. Okay, outside they say random forest. I will also go with random forest because the smaller the number of arrow, the better. All right. And now this one is having 88% of the variations being explained. So you can see in both metrics, SG is performing better than that. So we also have another model here called linear regression. Okay. So let's initialize linear regression. So I can say LR is equal to linear regression. Okay, let me just leave it empty also. All right, then I can always call my eval. Now, instead of XG, I will pass LR. That is the problem. The X input contains none. Okay. Linear regression does not accept missing variables. So where is the X that's having none? Let's see. So where are the nuns? How can we fish out the nuns? So let's do something like this. Will that help us to push out the nines? Oh, this will not work. So how do we normally get our nonce? So our X train is this. So for this, we say if it is DF, how do we get the nonce? Yes, we say dot is NA. Well, I know this is for data frame. Will it work for NumPy? Let's find out. Oh, it's not going to work for NumPy. Okay. So I think let's go back to this. Where is it? X train. No, the X scaled. So the X scaled is is na dot sum, is NA dot sum. DF dot is null. Okay, so the problem here, looking at this X train, it's not actually a data frame, it is NumPy array. So when you say DF dot is null, that is a method for data frame, not NumPy array. So maybe how can we fish out? So, or even this one is what? Is NumPy array. So maybe we can make this a lot of going back. Where's our original X? Well, we know that X there is no none. So let's find out. So this is our X. Okay. Do you know the problem? The issue is this ones. This where you are having this false and true. Because of this false and true, that is why linear regression is seeing them as none. This false is actually not a number. This true is also not a number. So if you want to use linear regression, it means you have to convert this false. Wherever you see false, you convert it to true. Wherever you see true, you convert it to false. Sorry, wherever you see false, you convert it to 0. Wherever you see true, you convert it to 1. Yes, so how do we make that conversion? Can anybody help us with this? Let's see whether it will work. Anyone, how do we convert this? Wherever it is false, we assign false. Wherever it is true, we assign true. Anyone? Anyone? Okay. Vincent is saying include detail equals to int. Oluwa Bukola is saying, okay. Thank you all for the response. So let's try each one of your responses and see how that goes. So Abdurrahman is saying we should say df dot origin Japan. No, if we do this, what will actually happen? All these values, they are going to become 0. So maybe this might not work. So Vincent is saying include D type equals to int. Will that work? Okay. And Chukozo is saying we should say df drop false true. That's the first thing that we did actually. All right. So let's see. Olua Bukola is saying we should say x dot replace. So I think let's try what Olua Bukola is saying. Let's try. Oh, Vincent is saying he is sure it will work. Okay. Let's see. So let's try this. Dot replace. So we can see what Olua Bukola has given us have actually worked, right? So you see here where we have origin Japan. Initially, this was false. Now it's 0. I mean, it's 1. This is 1 now. I mean, it was true now. It's 1, right? All right. So, okay. And although they are saying this replace function is deprecated and will be removed in the future, wherever. But nonetheless, we can make our life easy with it. So let's try that of Vincent. So Vincent, how do you suggest we include this parameter or this keyword argument? D type equals to int. How do we include it? Do you suggest we... Okay, inside the get dummies. So where is our get dummies? Okay, somebody is saying how different is this from what from get dummies that we actually do? So when you use get dummies, okay, where is it? So I've already transformed using get dummies here. Okay, let me do it again so that we're able to answer the question. So this is X after using get dummies. So here we can say, when we say X is equal to this, so you see, instead of 0 here, we're having false. Instead of true here, we're having 1. I mean, instead of 1 here, we're having true. So, but here, when we do this transformation, you see, instead of false, we're having 0. And instead of true, we're having 1. I remember your models, they always like numbers, right? So that's the difference between that. So, and also Vincent is saying we should do this in get dummies. So let's see. Say D type equals to int. Okay, let's see. Oh, so it's still, oh, Shagun is saying we should say X column is equals to D type int. Yes, I think this one will work. So let's see. So we can say X, the column name of interest, like origin Japan, dot as type dot D type Then we pass int. So let's see. Mm. Let's see. What is the issue here? Or should we do something like this? Mm. Or not as type. I mean, not data as type. Int. So you see, one will also say as type int. That's actually the case. And so you see, there are different ways of achieving your results. So here, what we can do, we can say our x is equal to, thus we can now override our original df origin Japan. So different ways of achieving your results, right? Good. Now, finally, after we transform our x, so I think this one, we can use this. So let me say my x is equal to this. All right, so having said my x is equal to this, it will mean that I will also have to come and do this transformation again. Where is it? So I get my S scale, I get this. So now let's try and see whether it will work. Input contains none. Okay. So this is an interesting problem, but I think you can explore it to see how to solve it. Or maybe after x scaled, we say x train. All right. So we see that okay. LR is having NAN. So now the challenge is to get those NAN, which I know you can do at your leisure time, and you make your life easy. But for the purpose of our discussion here, we may not be able to explore other solutions to this actual problem. All right. So this, then we also have SVM here, which you can also try. Just use your what? This function that we already create, which is called eval, and you make your life easy. All right, so after that, then we come back to our discussion. So let me check if there's any questions. Okay, no questions. So Michael, can you please help us launch the poll? And then I will hand over to you. And before I hand over to you, thank you very much for participating. Special thanks to all of you. And okay, and Tukozo is saying, what will happen if we drop the NAN? Yeah, so if we drop the NAN, the problem will be gone. So the only problem here is, in reality, when we check this, like when we check, where is it? Where is df.describe? And like when you check all this, none of the values is having null. So the problem here is when the model is saying there are null values, we need to fish out where the model is seeing the NAN. Then if we can fish them out, dropping them will be easy. So the problem is we don't know why the model is saying it is seeing NAN. All right. Yes, thank you very much for participating, and special thanks to all those that attend, and not only attending, also thanks to Abdurrahman, thanks to Shegun, Hafsat, Ngobe, Ntukozo, Timothy, Vincent, Vera, Busiswe, Olua Bukola. Okay, I think I've mentioned all those that commented. Let me see. Oliver, Ngobe, John, Michael, Kanya. Thank you all for participating, and even those that didn't comment, thank you all for contributing in this discussion. And oh, John is saying, can I comment now to be thanked to? Yes, you can. Thank you, John, and thank you all. Yes, so this will be my last webinar with you. So next week, a new technical mentor will take over from me, and I enjoy every bit of my interactions with you. And thank you all. God bless you, and I wish you $1 million in your bank account. Cheers. Over to you, Najoli.
Thank you, Mr. Buhari. I think Najuli is not on the meet.
All right.
So let me just take over. Thank you so much, and we really do appreciate you. Yeah, so for our next steps, your assessment, MCQ regression is due next week on the 13th April. Find your session recordings and resources on the program hub space on eHub. Remember also, you are not alone in the community. Engage with your squads, ask for clarity, and post your wins, challenges, and new insights on your squad spaces. Let's go to the next, and also kindly interact with our poll. We make sure that everyone has said something so that we can be able to make these sessions better and more good for you people, and so that we can be able to make sure that the next people who are going to be joining these sessions, they're going to get maximum benefits just as you have reaped. Yeah, so when you go to learning or technical support, we have three places that you're supposed to go to. The first one is Ask ALX. Ask the ALX team, programs team. This is the hub, the eHub space community where you ask any program or content related question. So please use this space only for these purposes. Most of you always go there to say hi to their peers, or to to say things unrelated to probably questions that need to be asked there. Also, the next one is the Fresh Desk. This is the to-go-to space for all program support. So this is whereby you go to, probably you have issues with your payments or just anything that is program related. Always log in the ticket there and you're going to be helped. Now, the one that most technical mentors are always there, the answer base. This is a channel specially dedicated for you to ask and get answers to complex content questions. So if you have any technical question, answer base is where you're supposed to go to. Yeah, we go to the next. Yeah, I think we were there. See you next. And as Buhari has said, this is the last PPL that is going to be with us. We hope to come back soon.